A very important programming concept is using for loops with vectors. So if you want to accomplish the same task for every element in a vector, you could use a for loop to loop through all of the elements in a vector. So you could say something like for I gets a value 1 to the length of your vector variable. So I is going to store the values of all of the indices from 1 to the end of the vector variable. And the action is going to be to do something with whatever your vector variable is called sub I. So that's the really important concept there, is using the loop variable I to index into your vector. So when I has a value 1, we're doing something with our vector variable sub 1. When I has a value 2, we're doing something with our vector variable sub 2. When I has a value 3, we're doing something with our vector variable sub 3, and so forth. So using the loop variable to index into the vector is a very important concept. Now, if what we're doing is creating a vector variable, it's much more efficient to pre-allocate the variable before the loop. So in order to do that, you have to know how long the vector variable is going to end up being. When you have a matrix and you want to do something with every element in a matrix, then you use nested for loops. So you need to loop over the rows and over the columns. So you're going to start by getting the size of your matrix variable and storing the values in two separate variables for the rows and the columns. And then you're going to have two loops. You're going to loop over the rows from 1 to R, and you're going to loop over the columns from 1 to C. And then you're going to do something with your matrix variable sub row comma col. So again, that's important. We're using the loop variables as the indices into the matrix. First the index over the rows, and then the index over the columns. So since the outer loop here is over the rows, that means we're looping or iterating through the matrix row by row. If I wanted to instead loop through the matrix column by column, then all I would do is exchange these two for loops. Everything else would stay exactly the same. I would still say the matrix variable sub row comma col. So you're always going to have the row index first and the column index second, regardless of the order of the loops. So if you want to do something in a matrix for every row, then your outer loop has to be over the rows. If you want to do something for every column, then the outer loop has to be over the columns. So this is, again, a very important programming concept. If you want to loop through the elements of a matrix, you use nested for loops to accomplish that. However, we're using MATLAB, so we want to use MATLAB wisely. So using for loops with vectors and matrices, again, a single for loop to loop through the elements of a vector, a nested for loop to loop through the elements of a matrix, that's a really important programming concept, and that's what you have to do with many languages, most languages. However, although for loops are useful in MATLAB, they are almost never necessary when you're performing an operation on every element in a vector or matrix. That's because MATLAB is written to work with matrices and therefore also vectors. So functions on matrices, operations on matrices, those automatically iterate through all of the elements. So you don't need to use loops to do that in MATLAB. So for loops are useful in MATLAB. For example, for the subplot function, that's a good use of a for loop. Or if you wanted to repeat the process of prompting the user for a bunch of values, you'd need to have a for loop for that. It's just when you want to do something on every element of a vector or matrix, that's when you don't need for loops in MATLAB. You can vectorize your code instead. So again, the term vectorizing is used in MATLAB for basically getting rid of loops. So taking what you would write loops for in a traditional programming language and instead using matrix operations in MATLAB. So for example, if you had a vector variable vec and you wanted to add 3 to each element, in most languages you would have to loop through all of the elements of the vector and add 3 to each one. In MATLAB, you can just say vec gets the value vec plus 3. So vec plus 3, that's automatically going to loop or iterate through all of the elements in the vector and add 3 to each one and then store the result back in the same vector variable.